Hello. Now, we're going to be talking about quadratic functions. Now, right here, you see a quadratic function in standard form. That means f of x is equal to a, the quantity, x minus h squared plus a k where a does not equal 0. If a equals 0, then we wouldn't have a quadratic function. Now, notice that this expression is different than the quadratic function ax squared plus bx plus c, where these a's are not the same a. It looks different. This is the general expression of a quadratic, but this is called the standard form of a quadratic. You can actually FOIL this and refix it, and you get back this standard, the non-standard form. But the standard form is very useful because it allows us to write a parabola that is centered and focused at hk. So let's say I have some parabola. Here's my h, here's my k, and the parabola opens up like this at h comma k. Well, I know for sure this function, f of x, is equal to some a times x minus h quantity squared plus a k, where h and k are various values. For instance, let's have a parabola right here, focused at 3, 4, opening up like this. What is the equation for such a parabola? Well, we're able to find out. Well, it's f of x is equal to a times x minus h, which is 3, quantity squared, plus r k, which is a 4. And although we don't know what a is yet, we can solve for it. Why is that? Well, because I know a point on the function. A point on the function here is f of 3, which is equal to 4. So that one is trivial, but whenever we pick that, that a goes away because 3 minus 3, even though you square it, is 0 times a is 0. So we got to find some other point on the function. Okay? Some other point, f of, let's say, 0, is then equal to a times 0 minus 3 quantity squared plus a 4. So then it's just a times a negative 3 quantity squared, which is just a positive 9. So that's 9a plus a 4 is equal to, I know, at 0, what is this function equal to? I don't know, right? I don't know if that function is equal to 0 whenever you go off to here. So that's something you need to be given, okay? So given that the function at 0 is equal to, let's say, 10. Now you can solve for a, because now we have this right here. Solving for a, I get 9a is equal to 10 minus a 4 is a 6. This implies that a is equal to 6 over 9. This implies I have a 2 over 3, which is my a. So the equation for this parabola, if it all at this point where it goes through here, this is 10. All right. If that's how that parabola looks like, then the function is f of x is equal to our a, which is 2/3, times x minus 3 plus a 4. And don't forget to square. Let's do one more example. Let's say we have a parabola and it looks like this. We know this is at 3, this is at negative 5, and right here it crosses this at negative 1, all right? So we know it's centered at 3, negative 5, right? So we know this function looks like f of x is equal to a times x minus 3 quantity squared, and we say plus r negative 5, so it's minus a 5. Notice that this is just like a vertical shift of negative 5. Okay. Now, I want to evaluate the function at 0 because I know it crosses negative 1 at 0. So f of 0 is negative 1, which is a times 0 minus 3 quantity squared minus a 5. This gives me a times negative 3 squared minus a 5. This is 9a minus a 5 is equal to this negative 1. I add 5 to both sides, I get 9a is equal to 4. Then a is equal to 4 over 9. Okay? So, this parabola, its function is f of x is equal to my a, 4 over 9, times x minus 3 quantity squared minus 5. So now, given a parabola, you are able to construct an equation using the standard form. Given some parabola, you are now able to construct the equation for that parabola in standard form.